Hi friends, we are going to continue next problem. Estimate the mass flow rate of steam in a nozzle with the following data. Inlet pressure and temperature is equal to 10 bar and 200 degrees Celsius. Back pressure is equal to 0.5 bar. Throat diameter is equal to 12 mm is given. Okay. So we are going to estimate the mass flow rate M. Okay. So now we are going to solve this problem. Solution given. Okay. So now what is the given data? You can write down here. So P1 is equal to 10 bar. T1 is equal to 200 degrees Celsius. P3 is equal to 0.5 bar. And D2 is equal to 12 mm. Okay. Now we know that for superheated steam, pressure of steam at throat. So P2 is equal to 0.546. P1 is equal to that is called P1. So 0.546 into P1 is called 10. Then you can write down here 5.46 bar. Okay. Now we are going to draw here molecular chart. Is this come from H? We know very well. This come for S, entropy. Okay. Now the point is representing A. The point is representing here for B. Then here also the temperature is going like this downwards. And now here the this is from for H2. You can write down here 982. Okay. So this is we taken from steam tables. Okay. I will tell you next. Next we go for point C, exist. Okay. In exist is also going like this. Now the pressure will going. This is for pressure lines. Okay. Now saturation line, and now this is also going like this, and now this also going like this. So you can take here already x2 is there, so we don't need to draw in here this line. Okay, this is the line for this. Okay, saturation line. Okay, this is saturation line. Now we know very well this is called P1, this is H1, H2, P2, P3, this is H3. Okay, this is the molecular diagram for this, and the molecular diagram for the expansion of steam through the nozzle shown figure. From molecular diagram we know that H1 is equal to 2A25. From molecular diagram H1 is equal to 2A25 kilojoules per kg. H2 is equal to kilojoules per kg. X2 is equal to 0.982. This is the value. Okay, and now we go for, we know that heat drop HD is equal to H1 minus H2. So H1 is equal minus H2. Then calculate this, we'll get the heat drop. Okay, now therefore velocity of steam at throat, velocity at steam, okay, velocity of steam at throat, that is equal to, you can know very well this equation. Now substitute the values in here, so calculate this, so we'll get the answer. Okay, next, from steam tables, at pressure P is equal to 5.46 bar, we find the specific volume of throat Vg2 is equal to meter cube per kg. Okay, and now here we go for area, to find the area of nozzle at throat. So then A2 is equal to pi by 4 d2 whole square. Now pi by 4 d2 is d is given, so then you can solve this, we get the area for this. Just we converted into meters, 10 to the power of minus 6 meters square. Therefore mass flow rate of steam, M is equal to A1 V1 divided by X1 Vg1, that is equal to 10 to the power of minus 6 into 480 divided by 0.986 into 0.345. Then solve this, kg per seconds. We need to convert this into kg per seconds, is converted into kg per hour, to multiply the 3600. Okay, so this is the solution for this problem, to find the mass. And next we go for another problem. Dry saturated steam enters a nozzle. Dry saturated steam enters a nozzle at a pressure of 10 bar and initial velocity of 90 meter per seconds. Okay, initial velocity of 90 meter per seconds. The outlet pressure is 6 bar and the outlet velocity is 435 meter per seconds. The losses from the nozzle is 9 kilojoules per kg of steam flow. Calculate the dryness fraction and the area of the exist. If the area at the inlet is 1256 mm. Okay, so ఇక్కడ మనకు ఏరియా ఇచ్చాడు, ఇక్కడ లాసెస్ ఇచ్చాడు. ఓకే, so this is someone to change this problem in here. Okay, we will see how to solve this one. Okay, solution. Given, you can write down first given. Here P1 is equal to 10 bar, V1 is equal to 90 meter per seconds. P3 is equal to 6 bar. Again here V3 is equal to 435 meter per seconds. Losses is equal to 9 kilojoules per kg. A1 is equal to 1256 mm square. Then you can write down here into 10 to the power of 6 meter square. Okay, so this is the given in problem. Now we are going to find in here dryness fraction of steam. So first one, we are going to find dryness fraction. Dryness fraction of steam. Let x3 is equal to dryness fraction of steam at the exist. From steam tables, at pressure of 10 bar, we find enthalpy of dry saturation steam. So H1 is equal to, and VG1 is equal to 0.1943 meter cube per kg. Okay, this is 3, and corresponding to a pressure at 6 bar. Okay, at 6 bar we find 6 bar we find here HF3 is equal to 670 kilojoules per kg. Okay, and alage HFG3 is equal to 2085 kilojoules per kg, and VG3 is equal to 0.3155 meter cube per kg. Okay, now we know that for a steady flow through the nozzle, H1 is equal to 1 by 1000 V1 squared by 2, that is equal to H3 plus 1 by 1000 V3 squared by 2 plus losses. Okay, this is the equation for steady flow. This is called steady flow equation in nozzle. Okay, so then here H3 is equal to H1 plus 1 by 1000 into V1 square minus V3 square minus losses. Then substitute the values in here. This is 2000, I think. So now here minus 9 losses is given. So then 2776.2 minus 99.6. So calculate this, we'll get the answer in here kilojoules per kg. Okay. Now we also that enthalpy of wet steam H3. Wet steam H3. So then 2676.6 H3, that is equal to plus H is I plus H2 HFG3. Now then here substitute the values, we will get the dryness fraction in here at exist. Okay, at exist dryness fraction you can find. Now so therefore x3 is coming. So now we go for area at exist. Area at area at exist, we know that here equation a1 v1 divided by x1 vg1, okay, that is equal to a3 v3, okay, a3 v3. Pointer is not working, but anyhow, okay, we'll solve this. x3 vg3, this is the equation, okay. Look at this, this is vg3, okay. Substitute in this equation, now we will get a3. So these are all values we know in here, okay. A1 we know, v1 we know, okay, x1 also we know is given, so vg1 also we taken from same tables, a3 also, a3 we don't know, so now we are going to find out a3 in here, v3 also we know, okay, and again here also x3 we find out, okay, and now here vg3 also we taken from steam tables, okay. So now all values we know except a3, so we can substitute these values and calculate, then we will get the final area at exist of the nozzle, okay. Next we are completed from nozzles, steam nozzles, okay. In next class onwards we are going to know about steam turbines, okay. Thank you.